Hi everyone, welcome to this tutorial. Today we'll learn how to get started on the Google Earth Engine Python API. So the Earth Engine is a cloud computing environment. It has two APIs. The first one is the JavaScript API and the other one is the Python API. Today we'll be getting started with the Python API. If you're new to Earth Engine, so the Earth Engine or the Google Earth Engine is a cloud API, cloud computing environment, which is free for research, educational and scientific analysis, and you can request access by going to this earthengine.google.com here and clicking here the sign up button. You can request a free account and you'll be granted access most likely in the next 24 hours. So once you have that account, then we can get started with the Python API. But before that, Earth Engine has various platforms. The first one is the code editor, for example. If you click here, code editor, so that's one of the JavaScript API where you can write your code and execute code. So this is the code editor API for JavaScript. You can write your JavaScript code to import Earth Engine database and execute code. And then here's the map canvas where you can visualize, your output. And then here's the console. You can monitor or debug your code. And that's all for the JavaScript API. But our focus today is the Python API. But before that, I'd like to show you, the various data sets that you can access on the Earth Engine API. So Earth Engine hosts, multiple terabytes of geospatial and satellite data set. You can access the, various data sets by clicking here the menu and also click view all data sets here. And there is climate dataset, geospatial data, satellite data, high resolution, moderate to coarse resolution datasets, dynamic land cover data, and some other geospatial datasets are hosted on the Earth Engine API. And so once you have your account, we can get started to the Python API. So to start with the Python API, you would need to have the Earth Engine account. By now, I assume you have an Earth Engine account, and you open a Jupyter Notebook. By way, to do that, you need to install either Anaconda or a Miniconda here. Here are the links below. If you go to the Anaconda website, for example, here, you can download Anaconda for your own platform, whether it's Mac or Mac or Apple. And on the other hand, if you're interested to the Miniconda, you can go to the Miniconda website and download a Miniconda for your environment, Windows, Mac, or Linux. And once you install Anaconda, to set up the Earth Engine Python API, what you need to do is just copy this here, conda create and GEE. That's just the name of the environment here. You can change this if you want to, and then the Python version. So and I'll copy this here. And then I'll create an Anaconda environment. To do that, I'll just type in Anaconda here. I have a Miniconda already installed. In your case, you need to install one. And then I'll just click that and paste the command that conda create -ng Python 3.8. So I'm defining or stating the Python version that I would like to install. This is the name of the environment that I'll be creating, GEE. And then this command should enter create my Earth Engine environment, and so I'll just go ahead and then hit enter. Okay, so Conda environment already exists. You like to install that. I'll actually change the name of the because I have that same environment. I'll try to name it differently. For example, I'll just name it a PyGEE, for example. That's just the name of the environment. It really doesn't matter. And just I don't want to override my current environment. That's why. So just to show you an example, I'll go ahead and install it. And I type in yes. Y for yes, and now it's installing the Python environment on my new Google Earth Engine Conda environment. Once I have that, we'll go ahead and open a Jupyter Notebook, okay? And perfect, now it's created an environment, and let's activate that new environment we have created. Conda activate. My environment name is PyGEE. You can just do GE in your case if you have created GEE. I'll just go ahead and hit that to activate this environment, and now this environment is active. So the next step is actually to open a Jupyter Notebook, and to do that, I'll type in Jupyter Notebook, and then I'll hit enter. Okay, so if it's a mini Conda, you need to install Jupyter, so a notebook. So you need to do like if it's Anaconda, it doesn't ask you this; it will automatically install it. So since my version is a mini Conda, I'll need to install notebook. Okay, so I'll type in Conda install notebook. So it's installing a notebook, and since I'm using a mini Conda version, and it's installing Jupyter Notebook from the mini Conda side. If it's Anaconda, it doesn't request you that; it will automatically install notebook. And once this is done, I'll open a Jupyter Notebook and get started with the Python API of the Earth Engine cloud platform. It's installing the Jupyter Notebook here. Let's just wait a little bit. All right, perfect. Now I can type in Jupyter Notebook, and it should open automatically now. All right, now we are opening a new Jupyter session here. Perfect. So once you open your Jupyter Notebook, I'll have here my new notebook on my end here. So the first thing you need to do is install Earth Engine or geemap, which has an Earth Engine built-in in that library. So I'll type in pip install. You can always install the geemap or Earth Engine on the Conda side, but there's recently a problem on that, so I prefer to do it on the Jupyter Notebook side using pip. So pip install geemap. So geemap is a library that has some visualization utility, which includes the Earth Engine library as well. So it's a nice tool to do some visualization on the Python API side. So I'll go ahead and then execute this pip install to install Earth Engine. All right, so it's installing here, successfully installed. All right, so okay, so the next thing is to import the libraries, the Earth Engine library. Import libraries. Okay, so the first library is import Earth Engine. So mind you, on the you need to import Earth Engine, and also you need to import geemap. Okay, and then execute that. Okay, if you're running it for the first time, you need to authenticate Earth Engine. So authenticate and initialize Earth Engine. You need to authenticate and initialize Earth Engine if you're using this for the first time in the Python API. What you need to do is you run authenticate. Okay, and execute that. All right, so it will ask you to generate a token that you can copy, paste, and authenticate your environment, your Python environment, and then you'll copy this authentication code here. And if you go to the Jupyter Notebook, enter verification code, I copied that, and then I'll paste that, and then hit enter. And now successfully saved and authorized tokens. So now you have successfully authenticated Earth Engine, the Earth Engine API using Jupyter Notebook. And next step is to initialize Earth Engine, and you do that by typing initialize, and I'll execute that. And it's initialized. And next thing is to create a map canvas so that we can visualize our map results. And I'll execute that. And if I call map here, it will open a new map canvas to visualize. Perfect. Nice. So this is our first map canvas, which is using an API leaflet, as you can see here. So whenever I import data, and I can visualize that using this Earth Engine map canvas. Okay, perfect. So next step is to let's import some data set here. So the first one the first data set that we'll like to import is the some countries database, right? If you type in on the Earth Engine data set here, data archive here, you just type in, for example, LSIB, it will automatically provide you information about that data set here. This is countries database, okay? So I'll just copy that, or just copy that data set here. This is a global, data set shapefile, to create some sort of, all right, I haven't copied it, so let me make sure I copied that. Click copy here, and perfect. So I will create that. The reason I need to import this is just to create a subset, because we're dealing with large global data, and then instead of analyzing a global data at this point, just want to select some subset area in some part of the world. So I'll create countries variable EE feature collection. So feature collection on Earth Engine is like a shape file in a more traditional GIS collection. So feature collection, and I'll import that ID. Actually, I should have done that as I copied it. Okay, and this is a global data. So next step is I'll filter one country instead of using the entire database, right? So I'll create ROI, just my region of interest here, and then I'll pass this countries here, and then filter. I'll use, so Earth Engine has a built-in filtering algorithms you can use to filter data. I'll use filter and EE filter equal. So this will select the attribute where it has the country's name, and then what name are we using? So I'll have to specify the name of the country. In this case, I'll be using Swaziland since it's a small country in Southern Africa. This will make it easier for me, and I'll execute that. Okay, perfect. And let's just make sure that we are able to map this. Add layer ROI. Swaziland. This will just give us a simple display. And also let's do one more thing to adjust the zoom level. Map center object will adjust the zoom level of this map, and let's just provide about 8. So 8 is the zoom level. And last thing is just to call this map. This is a map. Will generate a map canvas over here, and let's execute that. Excellent. So now we have our study region. You can go ahead and then click, check and uncheck that. So this is the boundary, a subset region that we would like to do our analysis here. And this is the boundary for Swaziland. So we've tried to map that and generate that. So next step is to import the Landsat data. And if you are new to Landsat, let's just go to this website here, datasets, and you can click here Landsat, and there are different satellite sensors for the Landsat satellite, and Landsat 9, Landsat 8, Landsat 7, and the other legacy Landsat sense instruments as well. And just to use Landsat data, you click that and you choose your own specific image collection, and you copy that image collection. Okay, so that's how you input Landsat data. And let's just close some of these windows here. And so for us, we have Landsat. Let's create a variable first, and EE image collection, and so I'm inputting an image collection for the Landsat 8. I can alternatively go ahead and copy that instead of that, copy and then paste it here. Okay, we'll need to provide a quotation here. We have 2 EE image collections, so we need to clean that. And Actually, we're using collection 1 for this example. So, and once we have that, let's create a filtering. So filter. So this is a global data, and in terms of spatial as well as temporal coverage, it covers the entire world, and it's also a longer time series. And then we want to filter it to some smaller time series as well as clip it by our study region. All right, here Swaziland. So what we're doing here is doing a spatial and temporal filter. And let's do filter date first. For now, let's use 2016 as an example. And that's the start date for our image collection, and the end date for our image collection would be 2017 01 01. So this will span for about a year data set. Okay, and let's also define the spatial coverage. In this case, our study region here, filter bounds, and let's provide a region of interest here, or ROI. Okay, next is to because if you're using a raw data, a raw Landsat data, it's cloud contaminated, and you have to do cloud masking or removing those clouds before you use it for any analysis. So let's use the Earth Engine built-in algorithm, which is called simple composite. So create a variable called composite, which contains the Earth Engine algorithm. So algorithms. And Landsat, this is an Earth Engine built-in cloud removal algorithm. Simple composite. Okay. And I'll create a bracket, and I'll open a curly bracket here, and I'll actually open a curly bracket over here. Okay, all right, and then I'll write my parameters here. So the simple composite algorithm requires two parameters. The first one is a collection. You need to provide the Landsat image collection. In this case, we have already imported our Landsat image collection here. I'll call it Landsat here. The other parameter is you need to define as the data type as float, and I'll just define that as true. And that's about it, and close my bracket here. And that's a function to do some cloud removal, so that we have a pretty nice looking Landsat image. And the next thing is to generate a visualization here. So visualization parameter here. So RGBVs. And let's create a band combination here. So what are the bands I'm using? And let me define the Landsat bands that I'll be using. I'll create a list of bands here. I'll use band 4. And the next one is band 3. So to generate an RGB or true color composite. Last one is band 2. And I'll define some minimum and maximum values for this visualization. I'll define my minimum as 0, and max is 0.3, and then I'll close my bracket. Okay, and the next one is to actually generate the map, the composite, the Landsat composite here by using map add layer. So that's a function to display your map. So I'll call this map composite here. and I'll have to clip it by my region of interest since it's clip ROI. So this will clip the Landsat image by my study area. Okay, and I'll also call the visualization parameter, which I already created here. And last thing is just to give a name, Landsat RGB. That's the name of the layer when you add it here. Okay, let's finally now execute our code here, and let's just one more thing. Let's create a map. This will call the map canvas over here. Perfect. So now we have our Swaziland boundary and our Landsat imagery here. We can zoom in here. So it's clipped and it's cloud free, and you can go ahead and uncheck and check. Remove the Landsat RGB here, and you can zoom in and look at the different areas within the study region. It looks pretty nice. It's cloud free, and you can do different band combinations to generate false color and true color composite, but this is just an example demo to show you how you can import Landsat imagery. This is some agriculture area here. So this is how you can write your Python. You can get started with the Earth Engine Python API. As an example, import a Landsat imagery and do cloud removal analysis and display your Landsat image. Thanks.